Hello, Challenge B. We're talking about logic this time, and we're going to look at Lesson 17. Lesson 17 is just on practicing proofs. So you know the rules of inference now, and you know the rules of replacement, and you're going to start putting those to use. So in Lesson 17, it's a hard lesson, and you can do it one of two different ways. You can either complete the lesson as they intend, where they just give you the premises and the conclusion, and then you have to come up with the proof on your own. Or if that's just too hard, then go ahead and do it like this. Have your parent complete the proof for you, and all you need to do is go over to the right-hand side and just justify each line using the rules of inference or replacement. All right, so I'll show you both ways. This second way is totally fine to do it that way if doing your own proof is just too hard. Okay, so first of all, let's look at number 1. This is number 1 in exercise 17. And we're given A, therefore, if B, then A. So this slash line just divides the premises from the conclusion. And we know that this conclusion is what we want to eventually get to in our last line. And so right away you notice that there's a B term here that we don't have in the premises. So we're going to have to introduce a variable. So the way we do that, which rule of inference just lets you add variables? That is addition. Okay, so we can take line 1, which is A, and just add a disjunction and a variable. And because, well, you'll realize later, but I just want to add a not B. So I used line 1, and that was the rule of addition. Okay, I want to go ahead and reverse these. And what rule tells me that I can do that? Not B or A. All right, that's the commutative. So we used line 2, and we used the commutative. Okay, and how can we get from a disjunction to a conditional? Well, to go from a disjunction to a conditional, we can just apply a material implication. And what material implication does, it just negates the first term. So instead of not B, you would have B. And it turns the disjunction to a conditional. All right, so if B, then A, which is what we need to prove. So we proved it. We used line 3, and we used material implication. Okay, so that's how we did the first one. Now the second method, let me scooch this over here, is by having your parent or somebody go ahead and fill in the whole proof for you, and then your job is just to justify each line, meaning tell me how you got from line 1 to line 2 to line 3 to line 4. All right, so let's look at this one here. We're starting with if C, then if D, then E. And this is our conclusion. So see, the conclusion is the last line. That's what we're trying to prove. All right, so how can we go from line 1 to line 2? What either rule of inference or rule of replacement tells us that we can do that? And look at exportation. All right, exportation will let us do that. So we did line 1, exportation. And by the way, it's really helpful if you have the rules of inference and the rules of replacement right in front of you. All right, I have them written down on a separate piece of paper that I wrote, but if you want to just have your appendix out with you, that's totally fine. It's not cheating to do that, although the more you have them memorized, the easier they are to use, but just have them handy so you can take a look at them. Okay, now the only thing that changed in line 3 is that C and D switched places. Now that one's easy, so that's the commutative property tells us we could do that. So that was line 2, and commutation. And then let's look at line 4. How do we go from this, or we could use any line above it. Let's see here. That is, look again at exportation. Okay, we had exportation. Yeah, everything stays in the same order. You just change the parentheses and from an conjunction to a conditional. So that was line 3, exportation. Okay, so again, if doing your own proof totally on your own is just too hard, then use this method here. It's totally fine, and these are kind of fun. So just take your time. Try not to get too frustrated. It is hard, but I think you can do it. All right, have a great day.